The trickiest kind of percent change problems look like this. Suppose that a quantity increases by 25%, ending at 50. We want to know what was the starting value. So again, we want to think about the start, the change, and the final. We want to think about the amount and also the percent of the starting amount. So here, the starting amount is what we want to know. Maybe we'll be able to call that x. And of course it's 100% of itself. We don't know the amount of change, but the percent change is 25%. And we do know the final amount. It's 50. Well, okay. Maybe the first thought that occurs to us is to set up a percent proportion. Right? We'd like to say that the change over our starting amount, x, is 25%. Uh-oh, though. We don't know the change, do we? So there are two numbers in this proportion that we don't know. Okay, well, we had this situation before, right, where there were two things in our percent proportion we didn't know. We had to try addition or subtraction, right? We had to say, well, maybe we can say that the change is the final amount, that's 50, minus the starting amount, oh, that's x. Maybe that's not going to work, is it? And it doesn't matter how we rephrase this sentence, it's still not going to work. We need to think back now. We need to look at this percent here. In this case, where we know the final amount and the percent change, and we're looking for the starting amount, we need to think of the final amount as a percent of the starting amount. And remember how we do that, right? So we know the final amount is the starting amount plus the change. But because of the way adding fractions work, we can write all of these as fractions with the starting amount as the denominator as well. So the final amount over the starting amount, that's the starting amount over the starting amount. We said earlier that's equal to 100%. The change over the starting amount, we said that's equal to the percent change. That's going to add up to the final percent as a percent of the starting amount. And for shorthand, I'm going to call that final percent. Again, the only time that we need to use this is when we know the final amount and the percent change, but not the starting amount. So, when this is exactly what our problem looks like, we know the final amount and the percent change, but not the starting amount, only then do we need to figure out that final percent. So let's do that. Right. In this case, the final percent is 100% plus positive 25% is 125%. So the final amount, 50, over the starting amount, x, is going to be 125 over 100, 125%. Notice that this will often lead to having to work with big numbers. That's why we want to avoid it as much as we can. We're only going to need it in this exact case, where what we're looking for is the starting amount. All right, we cross multiply. 50 times 100 is x times 125. This, of course, is 5,000. So x is going to be 5,000 divided by 125. Let's do that division. 125 goes into 500, I think, 4 times. 20, 8, 9, 10, 5. Yeah, 4 times exactly. Nothing left. But we have to write something in this place, right? And it has to be a 0. And so the starting amount was 40. We can always fill in this block, but the only time that we need it is when we know the final amount and we're trying to find the starting amount. Let me give you one of these to try. So suppose that a value decreases by 28%, ending at 18. What was the starting value? Use the technique that we just talked about, and remember that a decrease is a negative change. Pause the video and try this now. We want to know the starting amount, and of course that's 100% of itself. We don't know or care about the amount of change, but the percent change is a decrease of 28%, so negative 28%. And then the final amount was 18. We're in that case again where we know the final amount and the percent change, but not the starting amount. So we need to figure out what the final amount is as a percent of the starting amount. To do that, we'll say 100% plus the percent change, negative 28%, is going to be, well, 100 is bigger than 28, so this is going to be positive. The signs are opposite, though, so I want subtraction. I have to borrow. 10 minus 8 is 2. 9 minus 2 is 7. So positive 72%. If you weren't able to find the final percent, now that you know it, pause the video and try the rest of the problem. All right, we're now able to set up a percent proportion, right? The final amount over the starting amount, which is the base, is going to be 72%. Now we go to the cross products. 18 times 100 is x times 72. 18 times 100, of course, is 1800. So my x is going to be 1800 divided by 72. Let's do that division. Again, we're often working with big numbers in problems like this. 72 goes into 1, no. Into 18, no. Into 180 at least once. 2 or 3 times, I think only twice. 4, 14, yeah, 3 is going to be too much. 10 minus 4 is 6, 7 minus 4 is 3, bring down a 0. Let's see, 72 goes into 360. Let's try 5. 10, 35, 36. Oh, nice. Nothing left over. So my x is 25. That is, the starting value was 25.